All right. So more radio wave characteristics here. Um, Propagation modes. The atmosphere refracts or bends some radio waves slightly. Some signals bounce off the ionosphere and come back down. This is how most HF communications is done. So, 70 centimeters, the 2 meters, the 1.25 meters, 6 meters, those are mostly, 1.25, 2 meters, and 70 centimeters are line of sight. And there are calculations you can do based on this height right here from the ground while you're talking and come up with what your line of sight is likely to be in a clear open field. Over water, like when I go fishing over at Mosquito Lagoon and I have my radio out there, well, I have pretty good reach from there because it's nothing but water. But when you talk about HF communications, like with the 10-meter band, the 20-meter band, all those up there, your signal is going out. It's at some point or another, it meets the ionosphere and gets reflected back down off to the faraway land. So I've got Bulgaria and Hungary and some other places over in Western and Central Europe, and I think I've got one or maybe two contacts as far as the Eastern Bloc countries are concerned. So those are reflected, and sometimes they can be reflected multiple times. There are certain things that can happen in the ionosphere where it gets trapped up there and goes further. There are situations where it'll bounce off the ionosphere back down onto the Atlantic and then bounce back up and go further again. Now, every contact with the Earth saps energy from it. So that's why you have some of these guys out there running, 1.5 megawatt or 1.5 kilowatts of power. So UHF signals are usually not propagated by the ionosphere. VHF and UHF frequencies are generally considered line of sight. Line of sight signals are blocked by curvatures of the Earth. UHF in particular has some other things that are going to interfere with it. And remember, I told you about the formula. So visual horizon, you can figure out your visual horizon. The distance is roughly equal to 1.23 times the square root of the height. So if your radio is right here and you're talking into it, that's 5 feet 2 inches, 5 feet 1 inch. So you multiply, you take the square root of that and then multiply it by 1.23 in miles. So H is in feet, distance is in miles. And it'll give you a rough estimate of how far away your line of sight is. Maximum distance for line of sight communications is called the visual horizon. Radio horizon extends slightly beyond that. So roughly, 0.15? Okay. So about 15% further than what your visual, extends further than the visual. So your radio horizon, there's a formula at the bottom. The distance is equal to 1.414 times the square root of the height. Square root of, okay. Okay. Okay, and there's a visual of it, of your visual horizon. Okay, so when your visual horizon is a certain distance away, someone else talking from the same height that you're talking from down over the horizon could still reach that same visual horizon. That's where you come up with D1 and D2. So even though your visual horizon might be from here, your visual horizon might be 3 miles, someone 3 miles further out beyond that could talk to you because you would both meet at that point in the middle. We did this with they modified a fuel drop tank that no pilot wanted on their airplane because it meant they couldn't fly sorties. They had to fly comm missions. But they put it on a wing of an S3 or an A7 and go flying out 300 miles from the ship, and they could talk to another ship 300 miles down over the horizon because they could both reach that level, that point. None of the pilots wanted to fly it. It was hard to make it work because they just wouldn't turn it on. So, why is the radio horizon for VHF and UHF signals more distant than the visual horizon? And actually, I didn't cover that, did I? Your visual horizon is one distance, and then your radio horizon is because the radio signal has a tendency to bend a little bit. It won't bend at the same rate as the curvature of the Earth, but it will bend enough that you'll get a little bit beyond that. Like Bob said, roughly 15% beyond that. So back to the question, why is the radio horizon for VHF and UHF signals more distant than the visual horizon? Charlie, atmosphere causes, I didn't use the word refraction, did I? So the atmosphere causes the radio waves to refract, which is just to bend a little bit. Yeah, like orthogonal is the fancy word for right angle. Okay, why are simple UHF signals rarely heard beyond their radio horizon? Charlie, radio or UHF signals are usually not propagated by the ionosphere. Here, we use, in Indian River Amateur Radio Club, we use a 2-meter repeater. And the big reason why we use a 2-meter repeater, I think, is because there's a lot of trees around, and the leaves on the trees will absorb the UHF signal. They won't absorb the VHF. Propagation modes, multipath propagation. Signals arrive at a receiving station via 2 or more paths. This is called multipath propagation. So if you're, let's say you're on the outskirts of Miami and you're trying to talk to somebody else that is foolish enough to go to the outskirts of Miami, and you've got mirrored buildings over here, which you can bounce signals off of, and then you've got the straight line distance. So you say something on your radio and they receive it by straight line distance, and a split second later they receive it by the reflected distance. And that would be multipath propagation. Paths may be different lengths, so signals may arrive at different times. They will be, if they arrive at different times, they can be out of phase and completely cancel one another. They can be also in phase and reinforce. It just depends on what the distance is, and you'd have to do all that math. Moving an antenna a few feet may affect the reception. So if you have a problem, if you're talking to somebody on your 2-meter radio or your UHF or 70 centimeter radio, and you move a few feet, that may change your propagation significantly, either for the worse or for the better. Signal strength can vary greatly. Picket fencing is another phenomenon where you get rapid fluctuation, like when you're trying to, like you stand in front of a fan and talk into it as a kid, and it sounded funny. I still do it when nobody's looking. But that would be what picket fencing sounds like. Rapid fluctuation in received signal strength. Mobile operation location is constantly changing. So in my Jeep, and my Jeep is a particularly good example of it. I don't know if anybody noticed where my antenna is on my Jeep out there, but I've got a bracket at the bottom of the A-pillar on the driver's side, and that's where my antenna is mounted. Well, you've got the steel frame of the window right there next to the antenna, so it does get affected by that a little bit. But it also change of direction. So like in the morning when I'm going to Melbourne and I'm on 95 and I make a change in direction a little bit with the freeway, it kind of blocks out the repeater here in Cocoa. So usually about halfway I change over to the one on Holmes Regional. So it can affect it a little bit. That's why the preferred location for most people is on top. Now Jeep is hard to put an antenna on top. So they put a mount on the back above the spare tire that puts the antenna above the roof, and that does better. But my Jeep is one that does actually go in the woods, so I don't want anything sticking up that high. I tried to keep it below the roof line, and I also bought the absolute cheapest antenna I could find, because if I happen to hit a tree branch and then it bends a little bit and then goes over and then goes whack against another tree branch and bends, I'm not out a lot of money for an antenna. I just go grab another $20 antenna. Let's see, mobile operation. Digital transmissions require constant signals for, digital transmissions require constant signals for reliable communication. Multipath propagation can cause errors to occur. So with your digital, the only digital that I have tried is the DMR radio, and it is one of the most convoluted radios to program that I've ever seen. But in order for it to work, you have to have a signal that's unbroken. If it gets broken in the middle, then it starts to pixelate. But on the other hand, I can't talk with 5 watts from the airport in Melbourne to the SARNet repeater here in Cocoa. It's just too far. I can hit it well enough to make it unlock, but no intelligent, don't laugh, please. No intelligent communication at all. It can't, there's not enough left there for the radio to be able to put anything together. Now, the DMR repeater is roughly 1.5 miles farther away from the Melbourne airport than the Cocoa SARNet repeater. But with it, 5 watts, I'm crystal clear into that repeater, and they're roughly the same height. So the digital signal works with less signal and it's more consistent, but once it's gone, it's gone. With the analog signals, you hear them start to fade several miles before it completely disappears. Digital, you reach there, you know, can you hear me now? So, you know, it's like, it's fine right here, take 2 more steps and say it's gone right there. So I never thought of that can you hear me now thing until just now. But multipath propagation can cause errors to occur. And this is a representation. This is the Miami thing that I was just talking about. So this is a different types. And this is even worse because you're not standing still. You know, you're driving and your radio wave is propagating off the sides of buildings versus straight line and getting everything. So that's a good example of multipath propagation right there. Why do VHF signal strength sometimes vary greatly when the antenna is moved only a few feet. Alpha, Bravo, Charlie, Delta. Charlie, multipath propagation cancels or reinforces signals. What is the meaning of the term picket fencing? Bravo, a rapid flutter on mobile signals due to multipath propagation. Very good. What effect does multipath propagation have on data transmissions? Delta, I'm glad you said that because I'm sitting here thinking I can't remember if I emphasized that or not. Yes, on digital communications or data communications, your error rate is likely to increase if you suffer from multipath propagation. Repeater access, direct path line of sight. So remember, we said that VHF and UHF is line of sight communications. Now, just because you have a repeater doesn't mean that line of sight is no longer a factor. It's still a factor. It's still a factor, but because the repeater antenna is going to be at 150, 200, maybe even 300 feet, and if you're on N1 KSC, it's at 525 feet. It's up on top of the vehicle assembly building. So that antenna has a huge footprint. Direct path line of sight is preferred. Indirect path is a path that reflects signals to the repeater. So back to the Miami thing again. But you would have to know where the repeater is, where the building that you're reflecting off of is, and there's a lot of work that goes along to that, but you might have a few feet right there that would actually work. Direct antenna can bounce your signals off of a directional antenna can bounce your signal off of buildings or other instructions. Anybody know an example of a directional antenna? Okay, if you see an antenna that is like a beam and then it's got a bunch of cross members, can be 2, can be 3, can be 7, can be 15. That's a directional antenna, and it's set up so that it doesn't transmit more power, but it centralizes the power in a certain direction. And that's what's known as a directional antenna. And I can bring an example maybe of that when we... Is there more on directional antennas? Okay, so I might bring in a couple examples then. Indirect path, path that reflects signals to the repeater. Directional antenna can bounce your signals off of buildings or other obstructions. Knife edge diffraction, signals bend around sharp edges. Can't remember where the building is now, but a building that has a sharp edge like a corner or on top, something like that, can reflect the signal around that sharp edge. I don't know if reflect is the best. Refraction. Around a building in an urban setting, over a mountain peak in an outside setting. A good place to put an antenna is actually on a mountain way up high. Then you don't have to build as much mast or tower to get it up there. Plus you cover a wider area. If you put it on the ground on one side of the mountain, the other side of the mountain's blocked out. Absorption, heavy vegetation, and remember I said this a few minutes ago, UHF and microwave signals don't like vegetation. So UHF around trees is generally not the best idea. And GMRS is in the UHF range, and that's what every Jeep group uses instead of using 2 meters like they should. But the difference between GMRS and ham radio is with ham radio you have to take a test and pay for the license. With GMRS, all you have to do is navigate the FCC website and find where you pay your $35. Okay, repeater access. Here we go. So we're up on top of this rudimentary mountain with a tower and an antenna. And as you can see, they're talking to each other on opposite sides of the mountain. When using a directional antenna, how might your station be able to communicate with a distant repeater if buildings or obstructions are blocking the direct line of path sight? Okay, Bravo, try to find a path that reflects signals to the repeater. Okay, and I'm going to entertain you here for a second. We're talking, let's see. Well, it doesn't say what frequency. Okay, so I won't do that. Anybody look at C for a second. Try the long path. Long path is not something that a handheld antenna is generally going to do. Long path is when you go, like, if you're trying to talk to somebody in Melbourne, and instead of going straight to Melbourne, you go around the long way around the earth. That's the long path. And that can be done on some bands, but not on anything that you're actually going to be able to hold an antenna up for. Okay, propagation modes, knife edge diffraction. So here's a little example of knife edge diffraction. So you see the signals go in one direction, but it gets blocked out by that peak right there. But the sharp peak causes it to bend down and go to the ground on the other side. Which of the following effects may allow radio signals to travel beyond obstructions between transmitting and receiving stations? Alpha, knife edge diffraction. What is the effect of vegetation on VHF, and that's supposed to say UHF, on UHF and microwave signals? Bravo, absorption. So you don't you don't particularly have the absorption factor with VHF. It's a UHF phenomenon from UHF and up. What is the effect? See, we already said that. Antenna polarization. So every antenna that you look at has a particular polarization. So if the antenna is vertical, it's vertically polarized. If it's on its side, it's horizontally polarized. And when you transmit this, you want to try to match the polarization of the other side. The signal that they will receive will be significantly bumped down if the polarization is opposite. Okay, the orientation of the electric field with respect to the ground is what determines the polarization. So if the electric field is vertical, then your vertical polarization. If your, let's see, orientation of the electric field with respect to ground. Vertical radiator is vertically polarized. Horizontal radiator is horizontally polarized. The Yagi, the antenna that I just told you about, it'll be a beam with some cross members on it. If your cross members are this direction, when you hold it out, then it's horizontally polarized. If you turn it so that the cross members are up and down, your beam is still horizontal, but the cross members are up and down, then it's vertically polarized. And that can make a difference in communicating with that particular type of antenna. Polarization, UHF, VHF line of sight, cross or differing polarization causes reduced signal strength. So if you've got a vertical antenna and somebody else has a horizontal antenna, you might still be able to communicate, but your signal strength is going to suffer. VHF, UHF long distance. CW is continuous wave, in case not country and western like the music in my Jeep. Continuous wave, and it is Morse code. It's what they're talking about when they say CW. Single sideband horizontal polarization is most common. With UHF, VHF repeater, your transceiver, handheld transceiver, and because you're holding it like this and the antenna is going like that, is the most common. Back to where it's talking about CW and single sideband, SSB, single sideband. Horizontal is most common, but what's going to happen is if you're talking long distance and it bounces off the ionosphere, the signal starts to tumble. So it's no longer really horizontally polarized. It's not vertically polarized. It's what they call elliptical polarization or circular polarization. So at that point, it doesn't really matter what your antenna is. My antenna at home that I use all the time is a horizontal 40 meter, well, it's set up for 40 meters, but it's 66 feet long and it's horizontal, but it doesn't matter what the person in Europe that I'm talking to is, because at that point it's tumbling all over the place. And that's what this drawing is, right, Bob? Yeah. So you can see you've got a polarized signal at the top, but once it bounces off the horizon, off the ionosphere, it's kind of doing its own thing at that point. Cross polarization. Ah, okay. Yeah. So with your sunglasses and light. But you can see when you look at this, the more filters you put it through, the more it's reduced. What property of a radio wave defines its polarization? Let's see here. Orientation of electric field with respect to ground. So what property of a radio wave defines its polarization? The orientation of the electric field, right? What happens when antennas at opposite ends of a VHF or UHF line of sight radio link are not using the same polarization? So one antenna like this and one antenna like this, what happens? Bravo, received signal strength is reduced. Can be significant. What antenna polarization is normally used for long distance CW and single sideband contacts? Charlie, horizontal. Very good. Okay, so what it says down here at the bottom, the reason for this is that operators transmitting continuous wave or single sideband signals are often using what are called beam antennas, which is the Yagi. That's a beam with some elements on it. And it's much easier to mount and operate beam antennas horizontally than it is to mount them vertically. Takeaways. Line of sight is distance is equal to D1 plus D2. So you've got, each of you have a line of sight distance, and you add the two line of sight distances together. And it could be different for each side also, because on this end, we had a lady in here last week who will hopefully be back next week, who was in a wheelchair. So she's sitting in a wheelchair and talking on the radio, and the radio is only 3.5 feet from the ground. And you've got John over there talking on the radio 6 feet from the ground. So he's going to have a different line of sight than her. But when you add the two line of sights together, that's what your total line of sight is from one radio to the other. Line of sight is 1.23 times square root of the height, or radio horizon is 1.414 times the square root of the height, because of the slight refraction. Multipath signals arrive via different paths. If they're in phase, they will complement one another or add. If they're out of phase, they will deter from one another, so it weakens the signal. Rapid flutter on mobile signals is called picket fencing. This usually occurs while you're moving. High error rates on data transmissions, if you have signal that's in and out. Reflections from buildings can be used to reflect the signal. Knife edge diffraction is waves bending around sharp edges. Absorption, water, rain, trees, people absorb UHF signals, which is another reason why we use the 2-meter repeater more at Indian River. When it rains, the rain doesn't affect the 2 meters as much as it does UHF, the 70 centimeter. Polarization, orientation of the electric field relative to the Earth. Horizontal for long distance, vertical for line of sight. Any questions?